So automatically I can now calculate that distance. The distance will now be theta, which is 75 over 360 times 2 times, let's say 22 over 7 is our pi, which is a constant, times 6,400 cos alpha. And what is our cos lat? Cos lat is 32 degrees. Cos lat is 32 degrees. Cos lat is 32 degrees. Even everything here, we have everything here has been resolved here to be 5,427.5. So let's solve this. So we'll have 75 times 2 times 22 times 6,400 times cos 32 divided by 360 divided by 7. So we have 7,107.45 kilometers. 7,107.45 kilometers. That is our distance along the parallel of latitude. That's A2. If it takes an helicopter 9 hours to travel from P to Q, calculate its speed correct to 3 centimeters. So traveling from P to Q is still along the parallel of latitude. So we have to make use of this distance. Because P and Q, the distance between P and Q is along the parallel of latitude. So our speed here, our speed equals to distance over time. So since we have our speed to be equal to distance over time, so what's our distance? 7,107.45 divided by the time. What's our time? Our time is 9 hours. So we divide this by 9. What do we have? So we have 789.72 kilometer per hour. Okay, correct to the question now gave us that we correct to the nearest to 3 significant figure. If you have to convert this to 3 significant, you say we have 790 kilometer per hour as to 3 significant figure, because this one is the last. So we approximate this, we bring one and put here, and once we put one here, this one becomes 10. So 0, then 1 goes to the next line. So we have 790. That's 790 kilometer per hour. That is to 3 significant figure. 3 significant figure. The shortest distance. How to determine the shortest distance? So we have our sphere. We have our sphere like this. Let's say we have a point like this. Meeting here, and we have another one meeting here, like this. This is P, this is our Q, this is our B, this is our A. So the shortest distance, distance is equal to PAQ. So if you are asked to determine the shortest distance, PAQ, the formula is simply the shortest distance, PAQ, as this distance, is equal to 2 arcsine cos alpha sine theta over 2 divided by 360 times 2 pi r. That's the formula for calculating the shortest distance. Anytime we are asked to calculate the shortest distance, PAQ, we have to apply 2 arcsine into cos alpha sine theta over 2 everything divided by 360 multiplied by 2 pi r, where theta is the difference. Theta is the difference in longitude. Is the difference in longitudes, while alpha is our latitude. Alpha is our latitude. So let's see this example in figure 1.1b to justify the formula for calculating the shortest distance. So this question, example 1, says that 2 points A and B, both on a point parallel of latitude 41 degree north, differ in longitude by 56 degrees. Calculate the shortest distance between them along the surface of the earth. So here we have to apply this formula, but the first thing we have to do is to write our known parameters. Alpha is 41, theta is 56, pi has been given. Pi is 3.142, then our r is 6,400 kilometers. So the shortest distance is equal to 2 arcsine of cos alpha. What's cos alpha? Cos 41. Sine theta 56 over 2. Everything divided by 360 times 2 pi r. So here we have to resolve this. We have 2 arcsine cos 41 sine 56 divided by 2. That would definitely give us 28. Sine 28 times 2 times 3.142 times 6,400 over 360. So what we do here is cos 41 give us this, multiply by sine 28. So we'll have we have 2 arcsine of this result, which is 0.3543 times 6,400 multiplied by 3.142 multiplied by 2. That will give us 40,217.6 divided by 360. That is what we have. So what we have to do now is to find arcsine of 0.3543. So, and that will give us 20 points. So we have 2 times 20.7505 times 40,217.6 divided by 360. That is our shortest distance. So here we have 2 times 20.7505 times 40,217.6, then divided by 360. That will now give us 4,636.31 kilometers. So the question did not ask us to the nearest. The question did not ask us to calculate to the nearest degree, to the nearest kilometer. So here we have it, which is approximately 4636 kilometers. So this is the shortest distance on the Earth's surface. This is the shortest distance on the Earth's surface. Trigonometry. Graphs of trigonometric ratios. Having found the decimal values of the respective angles given the function y equals to sin x, the graph looks like this. Y equals to sin x. So you have a scenario like this, where let's say this is your 0 point, this is your 90, this is your 180, this is your 270, and this is your 360. This is our x-axis and this is our y-axis. The maximum value on the y-axis is 1, while the maximum value on this is on the positive y is 1, and on the negative y is -1. Then we still move on with this. -90, -180.